Welcome to G Fun Facts Online. What if I told you that the smartphone in your hand, the GPS that guides your car, and the future of medicine all depend on a science so strange it completely baffled Albert Einstein? Today, we're taking an odyssey through the quantum realm, a journey from bizarre theories to technologies that are actively reshaping our world. It's a story of human curiosity that started with a few glitches in the matrix of physics and has blossomed into a full-blown technological revolution. At the turn of the 20th century, physicists thought they had it all figured out. But a couple of stubborn problems, like how objects glow when heated, just wouldn't fit their perfect theories. Then, in 1900, a physicist named Max Planck, in what he called an act of desperation, proposed a wild idea. What if energy wasn't a smooth, continuous flow, but came in tiny, discrete packets? He called them quanta. He found the idea unsettling, but it worked. He had just fired the first shot of the quantum revolution. A few years later, Albert Einstein took this idea and ran with it. He declared that light itself was made of these energy packets, which he called photons. This was so radical that even after his famous work on relativity, Einstein considered his work on light quanta to be his most groundbreaking discovery. The decades that followed were a whirlwind. Niels Bohr created a new model of the atom with quantized orbits, and the picture of the subatomic world got stranger and stranger. But the real paradigm shift came in the mid-1920s, with pioneers like Werner Heisenberg and Erwin Schrödinger. They built the mathematical framework for modern quantum mechanics, and in doing so, introduced concepts that still mess with our minds today. At the very heart of quantum mechanics are ideas that defy our everyday experience. First up is wave-particle duality. Think about an electron. Is it a tiny particle, like a ball, or is it a wave, like a ripple in a pond? The quantum answer is yes. It's both. The physicist J.J. Thomson won a Nobel Prize for proving the electron was a particle, and his son later won a Nobel for showing it was a wave. That's how weird this is. This duality leads to another strange concept: superposition. This is the idea that a quantum particle can be in multiple states at once, right up until the moment you measure it. A simple analogy is a spinning coin. Before it lands, it's not heads and it's not tails. It's a blur of both possibilities. In the quantum world, an electron can literally be in multiple places at the same time. And then there's the one Einstein famously called spooky action at a distance, entanglement. When two particles become entangled, their fates are linked, no matter how far apart they are. Imagine you have two magic gloves in separate boxes. You send one to the other side of the universe. When you open your box and see a left-handed glove, you instantly know the other one is right-handed. The spooky part is that in the quantum world, the gloves didn't have a definite handedness until you looked. The act of observing one instantly determines the state of the other, faster than the speed of light. Now, this all might sound like abstract philosophy, but this is the science that powered the first quantum revolution, and it built the world we live in today. The transistor, the tiny switch that is the building block of every computer and smartphone, is a quantum device. Lasers, used in everything from Blu-ray players to delicate surgery, work because of quantum principles. MRI scanners use the quantum property of spin to see inside our bodies. Even the GPS in your phone relies on atomic clocks, which are governed by the quantum jumps of electrons. But hold on, because we are now living through the second quantum revolution, which promises to be even more transformative. This time, we're not just using quantum effects, we are actively manipulating individual quantum systems. The most famous example is quantum computing. A normal computer uses bits, which are either a 0 or a 1. A quantum computer uses qubits. Thanks to superposition, a qubit can be a 0, a 1, or both at the same time. This allows quantum computers to perform calculations that would take the fastest supercomputers millions of years. Imagine what we could do with that power. We could simulate molecules to discover new drugs in a fraction of the time, design new materials for hyper-efficient solar panels and batteries, and completely revolutionize financial modeling. And it's happening now. Recent breakthroughs in 2024 and 2025 have pushed us closer to this reality, with companies making huge strides in making qubits more stable. While a fully fledged quantum computer might be a decade away, experts predict the era of broad quantum advantage, where they outperform classical computers for specific, important tasks, will begin around 2030. Then there's quantum sensing. By using the extreme sensitivity of quantum systems, we can create sensors of unbelievable precision. These could lead to new medical tools that detect diseases at their earliest stages by sensing the faint magnetic fields from a person's heart or brain. They could also provide navigation that works perfectly deep underwater or underground, where GPS signals can't reach. And finally, there's quantum communication. Using entanglement, we can create fundamentally secure communication. It's called quantum key distribution, or QKD. In simple terms, if a hacker tries to eavesdrop on the connection, the very act of them listening disturbs the quantum state and immediately alerts the users. This is the promise of a truly unhackable internet, something our digital world desperately needs. Recent tests in 2024 even showed this is feasible over existing subsea fiber optic cables, paving the way for a global quantum network. Of course, this incredible potential also brings huge societal challenges. The same power that could create an unhackable internet could also be used to break all of our current encryption, threatening everything from our bank accounts to national security. This has kicked off a race to develop quantum-resistant cryptography. We also have to ask questions about fairness. Will these incredible technologies only be available to wealthy nations and giant corporations, widening the global divide? Establishing ethical rules to guide the development of quantum technology is one of the most important tasks of our time. From perplexing thought experiments to the tangible tech in our hands and on the horizon, the story of quantum mechanics is a spectacular testament to human imagination. We are standing on the threshold of a new age, where the bizarre, counterintuitive rules of the quantum world will help us solve some of humanity's biggest problems. The quantum leap has been taken, and our world will never be the same. Thanks for tuning in to Fun Facts Online.